Okay, well, it's a hard act to follow. There's a lot of interesting ideas in the previous paper and findings, and also there's a lot to cover in our paper. So this is joint work with Moritz over there in the back and Marcin. And the first part of the title, the CO2 question, is a reference to another title, and I'll mention that in a second. But before I get there, I want to point out something that many of you have read in the press, which is many statements from various important and knowledgeable people about the fact that green innovation is the silver bullet to the climate crisis. And let me start with Larry Fink in the latest letter to shareholders in 2022, where he says the next 1,000 unicorns won't be search engines or social media companies. They'll be sustainable, scalable investors, startups that help the world decarbonize and make the energy transition affordable for all consumers, right? That's Hyung-John's paper that we heard a little earlier, right? That very much fits. He could have quoted Larry Fink. And then a bunch of headlines, some from major news outlets. Here's another one: why green hydrogen just might be the silver bullet against climate change. And then tech billionaires bet on fusion as holy grail for business. And Bill Gates upbeat on climate innovation, even if 1.5 degree goal out of reach. For those of you who wondered, that picture is a picture of a fusion reactor. We are getting this stream of stories coming our way, and there's this faith in technology is going to fix our problems. And so if there's only one thing you want to take away from our paper, is that you want to put a question mark on that statement. So what do we do? Essentially, what we do is we are connecting innovation to carbon emissions. What's the effect of innovation? Green innovation and what we call brown efficiency innovation on decarbonization. It's helpful to really put out here two opposing views, although maybe the way we put those views are maybe they're not as different as I will just put it now. So view number one: green innovation fosters firm investments in green technologies and subsequent reductions in carbon emissions. Okay, so the point about this research under this view is that it focuses on the idea that you can direct innovation towards green innovation through a bunch of interventions, policy interventions, subsidies, pricing, and so on. And here's the important point: implicit in the conclusion of these papers is that if you can direct innovation towards green innovation, problem solved. In other words, once you get more green innovation, eventually you will get lower carbon emissions. Okay, that's implicit in the framing of these papers. However, we're going to take the other side here, or we're suggesting there's another way of looking at things, and I've broken it down into three separate views here, but they're all leading in the same direction. So first one, and this is where I want to appeal to back to the title I mentioned. So Jevons paradox, right? Jevons wrote a paper or a chapter in a book, I forget now, with the title, The Coal Problem. It wasn't the CO2 problem, it's the coal problem. What did he have in mind? He had in mind that, wow, think about when he was writing in Britain, right? Britain was heavily dependent on coal, and he was worried Britain might run out of coal. And then he was saying, yeah, but people say that we can save on how much we burn coal by making our technologies, energy technologies, more efficient, so that we get the same amount of energy with less coal burned. And then he points out that, however, there's a problem. Once you make the technology more efficient, you invite more demand. And the net effect is far from assured. You might actually get more coal being burned as a result of the efficiency technological improvements. Well, that's come to be known as the Jevons paradox. And why is that important? Well, because the same thing may be at work with green innovation. You may make the technology better, but you have to ask, what are the effects that the other potential effects, what's called rebound effects, that might come from that technological change? Okay, on 2B, there are two very important ideas that both go back to Ken Arrow, and one of them was actually relevant for the previous paper. The replacement effect. What does Ken Arrow mean by the replacement effect? Pretty much what we heard in the previous paper. If you have an installed base that works, why would you want to change it? Why would you want to replace it? And so if you have fossil fuel operations that work, why would you want to replace them with renewable energy operations? That's the replacement effect. And as you will see, we are going to take a much broader perspective on replacement effect than Arrow. The other important idea that comes from Arrow is the economics of learning by doing, which simply says, if you know how to operate assets that depend on fossil fuel, you learn how to operate them over time better and better, and then that's an impediment to switch to something else. And then finally, 2C is something you need to also take account of, and that's potential displacement effects. Now, displacement effects related to the idea of leakage. But as I'll point out, it has a fairly precise meaning in our analysis. Okay, so that's in terms of framing, and so in terms of questions, so we're looking over a time period, relatively recent time period, and we are asking basically the following three questions. Do firms switch their technological profile? You'd expect not, because of what I've just said, learning by doing and replacement effect. Is the impact of green innovation to reduce future carbon emissions? I've already sort of led you in a direction to wonder about the Jevons paradox. And are there important spillovers of green innovation to other companies' carbon emissions? Okay, and it's a bit of a monster paper, and I'm sorry you had to be the discussant, and it's really, you'll understand why it's a monster paper, because I'll explain a little later. One thing led to another, and we were responding to questions. We had to, keep digging. But very broadly, what this paper does is it combines three sources of data: financial information from Orbis and FactSet, patent data, it's a massive data set, and data on greenhouse gas emissions. And what you want to keep in mind here is that combining all of these three will, to some extent, limit us to the public, to the listed company space, because that's the, where we have the data on emissions, although we can say something about the private space as well, as I'll indicate later. Okay, and so, you know, this is our sample. You can see that the number of patents, green or brown, run in the hundreds of thousands. The average number of patents per firm is about 57. We have 62,000 observations with you know, all three sources of data for the extensive margin, and somewhat less, 28,000 for the intensive margin. All right, so a big first task we have is to say what's green and what's not green, or what's green, what's brown, what's other, okay? And we've had a hint of earlier talks. This is not so easy to do, right? So first thing you can rely on is that the patent classification, there's a patent classification system that allows you to get to first base. Say, you know, what's likely to be green and what's likely to be not green. And the OECD classification builds on that, and that's what typically the literature has used. Now we add a refinement. We distinguish within the OECD classification what's green, what's brown, you know, something that the OECD calls green, we, on closer inspection, find actually it's not green, it's brown efficiency. Brown efficiency means it's a fossil fuel technology that becomes more efficient. Okay, and to give you an illustration of how you can tell that not everything in what the OECD classifies as green is green, is if you do a word cloud analysis of the innovations, you can see what comes out as the main as sort of key terms, and you can see, for example, exhaust gas or internal combustion. That doesn't sound green, right? That's more like a brown efficiency innovation. Okay, and so let me now dig into some of our results. And so let me begin with the arrow replacement effect and learning by doing. So those two economic ideas, what they will give you is essentially path dependency in innovation, right? You do what you're good at doing already, and if you are familiar with some technologies, you are less likely to switch to other technologies. And you do find a lot of evidence, whether on the extensive margin or on the intensive margin, of path dependency. So let me start with the extensive margin. The variable any count EP stands for the number of patent filings at the European Patent Office. Okay, that's the important patent office here. We also do the US, but let me focus on the European patent filings. And what's driving that? You see that first variable that's driving this is past stock any. What does that mean? It means if you have a lot of patents to begin with, that's going to predict continued new patent filings. So if you're a big innovator, if you have the capacity to innovate, if you have lots of laboratories, you will continue innovating. Age is also very important. Size, of course, of the firm is very important. And so what this is telling you is that you have to be careful to control for innovation capacity of the firm. And here's another set of results. Oops, I think I skipped that. Oh, I must have skipped another. Yeah. So let me continue and just say that in order to account for the fact that capacity is a big driver of innovation, you want to, instead of looking at the count, you want to look at ratios. And so what we are then looking at in terms of outcome variable is, in terms of explanatory variable, is the green ratio. EP again stands for European filings, and brown ratio. What's green ratio? It's the number of green patents filed divided by the total number of patent filings in that year. Okay, and so what's our empirical model? Well, we begin by trying to understand what predicts patent ratios. Then we look at the link between emissions in the future as a function of the patent ratio. And we also look at other policy outcomes, corporate policy outcomes, as a function of the patent ratio. That's what I was looking for earlier. I've forgotten where in the order I put this slide. So here what you find is that what predicts green patent ratios, it's just look at column 1 here, for example, actually, no, you want to look at column 2. What's the difference between column 1 and column 2? In column 2, we have industry fixed effects and industry year fixed effects. And so what is column 2 telling you? It tells you that if you have high direct carbon emissions, that's the log of total scope 1 emissions. If you have high direct carbon emissions, that means you're really, a fossil fuel dependent company. Well, guess what? You're going to do less green innovation. However, if you have a large stock of green patents already, then you will continue to do green innovation. And if you're a young company, you will also do more green innovation. And then if you look at the right-hand side for brown efficiency patent ratios, you will find it goes in the other direction. If you have high emissions, you're more likely to do brown efficiency R&D. If you're an old company, you're more likely to do R&D, brown efficiency R&D. And the same holds true for the intensive margin. In the interest of time, let me skip over this quickly. However, here, this is an important slide. So it's asking similar questions before, but notice what we do here is we break things down in terms of whether you have direct emissions or indirect emissions, scope 3, scope 2, and we're looking at scope 3 upstream and downstream. Okay? And what you find is you can see here again, if you look at, for example, for upstream scope 3, if your upstream scope 3 emissions are high, you're less likely to do green R&D. And the same is true for downstream scope 3. And however, if you're doing brown efficiency innovation, you're going to do more of it if your scope 3 upstream emissions are high. So what is this telling us? It's telling us that the replacement effect, it's not just about your own operations. It's about the entire ecosystem you're in. So if you're dependent on suppliers that use fossil fuel technology, it's going to be harder to switch. Similarly, if you're trying to switch from, let's say, combustion engine cars to electric vehicles, you can innovate, you can produce your electric vehicles, but then you depend on the entire ecosystem of how these vehicles can operate. And so the replacement effect is really an ecosystem replacement effect. All right, so I'm told 5 minutes, so let me now jump to the second part of our analysis, and that is what's the effect of all this? This is the main part of the paper. What's the effect of all this on emissions? Okay, so is this actually making a difference? And I can tell you that it's disappointing, to say the least. Maybe you knew this already, but certainly it was a surprise to us. So look here, for example, on the effect of green innovation on direct emissions 1 year in the future, 3 years in the future, 5 years in the future, and also the effect of the average over 3 years in terms of green innovation on emissions. And you just look at this side, on the far side of the table. There's nothing significant. Nothing significant. Okay, so conclusion number one: green innovation has not resulted in significant carbon emission reductions for innovating firms, even after 5 years since filing the patent. And we do another robustness test, which confirms that, which goes even further into the future. I don't have time to report that. Okay, then look at this bottom here. Brown efficiency innovation. And what's the effect of brown efficiency innovation on emissions in the future? It increases emissions. Yeah? And then look over here. What's the effect of brown efficiency innovation on sales? It increases sales. So what you find? You find brown efficiency innovations result in increased future emissions because basically that's the Jevons paradox at work. Is you innovate, become more competitive, your sales increase. So you do have a small improvement in scope 2 emission intensity, but this is undone by the increase in sales. Okay, so a bunch of things you could, reactions you might have to this. You might say, well, 1 year, 2 years, 3 years, that's not far enough in the future. 5 years may not be far enough into the future. Maybe when you have an increase in green innovation, all that does is a small incremental change, and so that's why you don't see anything. And then you might also comment that we've had in early presentations that innovation may be patented in a particular firm, but it's really destined to lots of other firms. So maybe where we're looking is the wrong place, so we need to look elsewhere. We need to look at other firms, we look at other industries, et cetera, et cetera. And that's why the paper has become a monster, because we had to essentially respond to these questions. Let me skip over this and tell you a very quick summary of what we find.
We were ahead 5 minutes, so you take an extra couple of minutes. We'd like to hear.
Oh, all right. Okay. So then let me show you this table. This is the table from the IEA report, and it tells you a big part of what's potentially driving our results. You can see here that they're looking at technological changes that will reduce carbon emissions. And you can see that starting from 2019 up to 2070. And you can see most of the stuff that will make large reductions in carbon emissions is in prototype stage, demonstration stage, early adoption stage. Yeah? So they're huge lags. That's a big lesson here from the IEA report. Okay, so what do we find in terms of spillovers to other companies in the industry? So you have an innovating firm, produces new green patents. How is that affecting carbon emissions of other firms? Well, we find that green innovation actually increases future Scope 1 emissions in the same industry. So this is not just confined to the innovating firm. Here's the important point about displacement effect. Green innovation is associated with higher future Scope 2 emissions. If you think about that, it's obvious. So Scope 2, by the way, Scope 2 emissions is emissions for the production of electricity and heating. Yeah? So I've picked here 4 states for you that tell you how electricity is produced in these states. West Virginia, 91% electricity comes from coal. So if you go and switch to electricity from some other fossil fuel energy source, all you're doing is you're displacing the emissions. You're no longer emitting, burning your own fossil fuel, but you have the power company that supplies you the electricity burn its fossil fuel. Okay, there's no effect of green innovation on subsequent carbon emission reductions for all innovating firms in the industry, for all non-innovating firms in the industry. What else? When you look at brown patents, you find that there's some reduction in direct and indirect carbon emissions following greater innovation, brown efficiency innovation, but it's a statistically insignificant effect. You find that looking at all innovating firms in the same industry, emissions are actually increasing slightly. And if you look at the effect on all non-innovating firms, you find that emissions are slightly lower. Okay, how do you make sense of all this? Well, let me jump ahead and show you one important story here that may be explaining these results. So this is the innovation market share. And if you want, broadly speaking, what's the idea? The idea is if you are a brown efficiency innovator, that makes you more competitive relative to non-innovators in the same industry. So you gain market share, the non-innovators lose market share. So your emissions go up because your market share goes up. That's the Jevons effect. Their emissions go down because they lose market share. Yeah? And for green innovation, what's interesting is green innovation actually sets you back competitively. You're less competitive to begin with. And so you lose market share. And you can see that it's really the companies that are innovating the most in terms of green innovation that are losing the most market share. Okay, so I think, so one other result and then I'll conclude. So here's where we can rely on the fact that we have all the patents. So our data set has patents of all companies, whether they're listed or not listed. It's a massive data set that's put together by Orbis. So one thing we can do is we can ask, what's the effect of the innovation in private companies on the emissions of listed companies? Yeah, we can ask that question. And by the way, these innovations in the private space, they include the VC innovations that we heard earlier. They are in here in our data. Well, what you find that neither public nor private innovation is associated with any reductions in industry level emissions. So that's where basically the upshot of most of our findings. We don't find much. Let me skip that last slide and let me just summarize what we find. So we find that basically companies that do green or brown innovation, first of all, tend to be already green or brown to begin with. There's a path dependency. And then companies that do more green innovation, they are not able to significantly affect emissions because a lot of it is happening because of Jevons paradox, as I mentioned, and a lot of it is also happening through the displacement effect, as I mentioned, with scope 2 emissions going up. And so, what's the big pitch, if you want, of this paper? What's the big conclusion? First of all, make sure I have a question mark on when you see silver bullets anywhere on a technology. And second, it's not completely surprising that innovation will not necessarily make a huge difference in terms of emissions. Why? Because you need so much more. And in particular, as I pointed out, the ecosystem replacement effect is a huge impediment. You need to coordinate innovation through the entire supply chain to really make a difference. And you then need policies to scale up the innovations. But the idea that you can let the market come up with these great discoveries and somehow provide the solution without any public policy intervention, which is sort of what's implicit in these statements that we hear about silver bullets and so on, that is a misleading idea. You need both innovation and public policy to coordinate and scale up the transition.
Thank you, Patrick.
Okay, so first of all, thank you for asking me to discuss this paper. Actually, I really enjoyed reading it, and it was a pleasure to think about these issues. And I'm sure that from the initial masters, there will be many papers coming out. So let me start discussing why I do think that this is going to be an influential research project. Well, as Patrick was saying, we have been thinking of innovation as the silver bullet to decrease emission and to lead us to a transition to a climate neutral economy. And this has been affecting research. So, for instance, there are papers that suggest that we should favor the funding of companies that are brown, or companies in brown industries, because these are the companies that can invest more to change their technologies. So, and these would be also the companies that, according to rougher categorization of green innovation, wouldn't be making more patents. And this sort of idea has been affecting not only research, or also more descriptive paper that just want to measure which companies are investing more in transition using patent, but also policy. So I'm thinking of the European Green Deal, the Inflation Reduction Act, and so on. And no one so far has been asking the basic question, that is, but do we really observe that green patents then lead to lower emission? Is this a good proxy in measurement of green company, more descriptive paper, and is the right thing to do? So I think that so far the main contribution of this paper is actually providing a conceptual framework for why the answer is not obvious, and actually all these patents that we classify as green might not lead to lower emission. There are two main arguments. One is, well, it is true, as Lauren Cohen and Umit Guru measure, that companies in brown industries have more quote-unquote green patents. But Patrick and Marcin would tell us, well, wait a moment, those patents are not so green, is what they call brown, relatively brown patents, because these are patents that make the use of fossil fuel more efficient. And since they decrease cost, there is the notional possibility that well, they lead to larger aggregate emission, if not necessarily to lower emission intensity. So I believe that in the paper, all what we saw about emission is absolute emission, not emission divided by sale. And then there is the other issue that, of course, companies don't want to cannibalize themselves. So brown companies may have many patents, and many patents that we think are green, but these are sort of very complementary to the existing technology. So overall, so basically brown companies do not engage in actual green R&D, okay? So, and then there is what indeed I think is the most important part of the paper, that is when the different type of patents are related to emissions. And these are emissions for the patenting firms, but not only, because those are technologies that the patenting firms can sell. So it is important to know that a very important innovation could affect other firms in the industries, or also other firms in related industries that are related to input-output relationship. But overall is a very detailed empirical analysis shows us that there is no consistent effect of patenting on absolute emission. So the tables, as you saw, are a bit of a monster, okay? So what I would suggest here is that I believe the result, I believe the conclusion. I think that, and it is comforting that the results are there for so many proxies, but perhaps there should be some favorite proxy to have a main story and so on. So before getting more in details to the comments, is the paper, the way I read it, was giving a very dark sort of conclusion. Innovation doesn't help. So I started to ask, okay, but what can work? And if we look at the way in which economists have been thinking of the climate transition, is that to some extent a carbon tax, and especially a global carbon tax, because there must be a level playing field, could work and could actually make green innovation work. And what I have in mind is that, well, if a carbon tax makes using fossil fuel more expensive at the margin, companies could have incentive to innovate, but at the same time, the marginal cost would be higher, so prices would be higher, and there wouldn't be the Gibbons effect, or would be attenuated. So Gustav, Per have a nice paper for Sweden that show that carbon taxes may work and may actually encourage innovation. And it would be interesting to think of the interaction here. And this data set is perfect because it's an international data set. And we could know whether, for instance, some of these patents are associated with a decrease in emission in countries that have already associated carbon taxes. Now, I am particularly interested in this because there have been the only paper, I think, that has looked at the association between a green patenting and emission is a paper of Uli Ege, co-authors, that uses just US patents, okay? In the paper I read, I believe that Marcin and Patrick were using only the patents of the European Patent Office already. So I'm wondering what drives the difference. One could be measurement. The other could be that perhaps these US patents are from California that has carbon emission regulation, but it would be interesting to know more. The other idea that I had listening to the presentation is that this could just be specification, meaning that in the specification that Patrick presented us, we were finding no effect on emission or with a firm fixed effect. That means that an additional green patent is not associated with future lower emission. But in principle, these firms that do more green patents could have a lower emission than others. They are specialized. So this could be a difference also from that paper, but it would be a broader important question to ask. Now, one curiosity, and probably would be another paper, for sure not for this paper, is that when all these measures of green and brown patents that we have seen in the paper relate to patents that have been internally produced and also to patents that these companies are purchased. Now, if I believe to the extreme into the displacement effect, I would think that some of these brown companies that hold many of these either efficiency-related or real green patents may actually really buy this patent not to displace their technology. So I am wondering if there is a different effect when we distinguish between patents that are produced in-house and patents that are purchased, and especially if these purchasing patents by brown company can be a sort of cannibalizing acquisition, as had been shown in a different contest in a recent paper by Ederer and Marr. So this is a bit related to the measurement of patent. So currently the main measure is a ratio between the all innovation ability of the firm and these green or relatively less green patents. So again, what matters is being innovative, is a company fixed effect. Perhaps the first batch of patent would matter most. But in general, if we think in terms of silver bullets, we should think a bit as of unicorns. And not all the startups are unicorns. So I am wondering whether there is a large heterogeneity in these patents. So one harder way to think of it is to try to look at citations, patents that are really a breakthrough because they do not cite much previous research, but are cited in future research. But also looking at some quantile regressions, because currently these effects on the emission are on the average effect, but in principle there could be some patents in the lowest quintile that are actually very effective for their own firm and so on. And those are the green unicorns. So there are now in this literature about green finance and measurement is always important. As Patrick said, is that perhaps we don't have a long enough sample. And I would like also to have a discussion about how we should measure emission, because there has been a consensus in the literature moving towards intensity. Of course, that doesn't capture the Gibbons effect, that is an aggregate effect, but this should be clearly spelled because the policy implication and the implication for what we do are very important. And yes, this I hadn't understood well enough that there were already all the patents, and not only the patents filed with the European Patent Office. I am wondering if these patents can be a bit different. Sometimes we know that firms patent just to appropriate innovation, but those are very small innovations, and this is a bit related to the Hege paper. But overall, I think that these are very extremely important questions. Just starting to think of it is a huge contribution. The data set is terrific, and I mean, I'm sure there will be many papers to come. So.